everyone, and welcome to the Mabb Lab. My name is Dina Yakut. I'm a fourth-year PhD student in the Mabb Lab at GSU. Our lab is interested in studying mechanisms of learning and memory at a molecular level. Today we have some fun activities for you to demonstrate concepts of learning and memory. Normally, you would come to our exhibit booth and we would do these fun activities together, but don't worry, we'll show you how to do it at home. I'd like to thank my friend Zach Allen, the lab tech in our lab, for helping me out today. So let's get started. For our first activity today, we have the mirror tracing activity. First, I'm going to try and trace the outline of this star shape. There we go. Next comes the challenging part. I'm going to place a mirror in front of my paper and then hide it so I can only see the paper in the mirror, and then try tracing the figure again. Oh, as you can see, I'm really bad at this. But probably, as I keep practicing, I'll keep getting better. This type of memory is called procedural memory, which is the memory that helps us remember how to do things every day, like climbing the stairs, or riding a bike, or driving a car. This is different from episodic memory, which is our memory of events that happened in the past or things that happened throughout our day. Research shows that some patients who lose their episodic memory still retain their procedural memory. Psychologists use this mirror tracing task to assess the patients with memory impairment and their ability to do procedural tasks. So the patients can come in every day and practice tracing a figure in the mirror and keep getting better at it, even if they don't remember that they've done this task before.
Next, we have the Prism goggle experiment. Basically, I'm going to throw this ball into the bucket several times just as practice. As I'm doing this, my brain is not compensating, but adjusting to the distance and the placement of the bucket. Next, I'll try throwing again, but this time wearing the Prism goggles. These goggles actually shift the visual field to the left quite a bit, so I'll probably miss several times. So now we'll try again with the goggles off. So this experiment explains and demonstrates visual motor plasticity. This is the ability of your brain to adapt and compensate for challenges in your visual field, much like squint patients adapt for navigating in their environment. As I put the goggles on, my vision shifts to the left, and slowly over time and over tries, the brain learns to adapt for this challenge. Surprisingly, when I take the goggles off, I miss a few times as well, to the opposite direction. This is from the compensation that my brain made for when I was wearing the goggles versus just looking at it with my bare eyes.
So next, I'm going to show you some of the brain areas involved in the concepts of learning and memory that we've discussed today. This is the precentral gyrus, house of the primary motor cortex, which is responsible for coordinating most of our motor activities every day. This is the cerebellum, also responsible for motor coordination and responsible for the procedural memory that we've discussed. This is the visual cortex, responsible for visual representation and visual processing every day. Thank you for watching us. Remember to wear your masks, wash your hands, and stay safe.